Okay, geographers, let's get going with our actual analysis, spatial analysis, and assessing what happened with Hurricane Katrina. So I've got the 4.1 PDF opened up. And again, as I was getting into, I think I got into it in the last video. It seems like an eternity ago. But this comes from this Esri Press uh, tutorial book, and it's one of the few that I actually really like with how they've set stuff up here. Um, and so we're gonna go through 4.1. I'm gonna read through, point out some key things I like from here. Some of this stuff I'll have you do on your own, but other things I'll guide you through. Especially some of the raster analysis stuff. That'll probably be the third video for this stuff, just to get into what they're doing with some of that cool raster stuff. But with this chapter, they're looking at Hurricane Katrina and what happened in terms of damage. And we tend to think of Katrina as hitting New Orleans, and yes, it was a disaster there, but it wrecked the entire Gulf Coast. So in this example here, we're looking at these coastal Mississippi counties right here that were wrecked by the hurricane. Didn't get quite the same national media coverage because New Orleans stuff was so shocking and the images were shocking. But the idea is we're going to look at that. And so what this book does with these different chapters is they give you this scenario talking about how Katrina hit the coast. And so what we're going to do is to assess and remediate the damage caused by the 15-foot storm surge that hit the coast. Your team of GIS specialists must prepare maps and calculate damage. Isn't that exciting? Like you're leading a team. You're in charge here. So a few things. It's kind of telling you what we're going to be doing. This 15-foot storm surge is going to be key down the road. File that away because that's a big part of hurricane damage and what we're going to be looking at. So remember that number. But this is the kind of deal when you're doing GIS work. It's like, okay, we had something happen. Let's figure it out. Let's see what actually took place. And the information here, this final sentence, will help federal officials decide how to allocate redevelopment resources. So what they're saying here is, what you're doing, you're not actually making real decisions, but you're going to be getting some information to the people who can actually make the decisions, right? Who have the power to be able to say, okay, this county gets money for this specific thing, this county gets money for that thing, that kind of deal. So what we're trying to do is just prepare this nice, unbiased, very clear, presentation, whether it's maps or tables or whatever we wind up producing, to say like, here's what the reality looks like on the ground. So take this information and make your decisions with it. Okay? This is, I think, pretty realistic to what you do with GIS. You're not always the person who gets to say, so here's what we're going to do. You're helping the people who make these decisions, right? And ethically speaking, we should be trying to do it in an unbiased way, but also keep in mind that you know what's going on. You're looking at the data. So you have this ability to, highlight certain things, focus on certain aspects. You're making some decisions as you go. So something to think about there. So we scroll down, and it gets into, some environmental aspects of this thing, like why we actually care about the coastline, not just for the people, but getting into the wetland environment and all of that stuff. Problems here. It's kind of bringing the scenario into a more specific GIS focused thing. Like, what are we going to do? And effectively, if you read through here, which you should read through all this stuff, but it's getting into three main things. We want to assess the total acreage of different land cover types, and that's some of the data that they provided us with. So see what was actually flooded, what was under this 15-foot storm surge. It's talking about mapping unique hydrography. It's just that part of this isn't that thrilling. But it's basically there's the flooding, there's the damage to infrastructure. Very like they focus on healthcare centers in here, so we kind of get a sense of what not only where was the flooding, but what was flooded, what's actually damaged and potentially destroyed, and all of that. And so, with this, we're gonna provide this information, and I think. Yeah, so saying about your team must prioritize locations for disaster aid, justified by the data provided in the maps, graphs, and tables you produce. As with many of the complex problems that confront us, there's not a single right answer. I like this too, because that's a big thing with GIS. Very rarely have I ever done some work where I've gone, aha, here's the one and only answer to this situation I'm dealing with. No, it's more a case of, well, this is kind of, the right answer, but so's this here. And this right answer is actually a better right answer, right, as they say. However, some answers are better supported and justified than others. So very rarely are you going to say, aha, X plus Y equals Z. It's going to be more a case of, yeah, here's what it looks like. Let's talk about it. There's no real obvious right answer. So I kind of like that. Within this chapter and the next one as well, they've got these questions, Q1 through 4, and it says record answers on your worksheet. There's a Word document in that initial zip file that you download. You don't have to do this at all. I'd say read through. It's kind of useful to think about, which geographic area are you studying? Might seem like, isn't that obvious? Well, it's good to think about this stuff, but we're looking at the Gulf Coast and specifically the Mississippi Gulf Coast. What decision do you need to make? It's getting into, where are funds going, right? What information will help you make the decision? And so this is where it gets kind of useful. Okay, we need to figure out where do we send money to help things out. What information will help make the decision? Well, we need to look at where's the damage, right? That's the idea, and kind of the broad sense of it. But you want to be thinking about this if you're working on your own, if you're not following some little tutorial thing here. You want to actually, list this out. Have either a document on your computer or a notepad next to you or a whiteboard or whatever it might be. Like, write this stuff out. Take lots of notes as you're going through. And then who are the stakeholders for this issue? And this step is important. We get stupid AI. You need to know the audience for your analysis to help decide how to present your results. That is important right there. Now, stakeholder, it's an overly used term. It's actually, I think it's a bad term because it kind of waters down the people who actually, have a stake in what it is we do, because we just tend to say stakeholders and we throw it out. And we're not thinking about actual human beings or government agencies or whatever. But stakeholder simply means who is affected by the work you're doing, by the project, by the analysis, or whatever. Now with this, you could say, well, isn't everybody in the state of Mississippi and all tax-paying, American citizens are technically stakeholders? And yeah, that's true. But really, the idea with this is we're producing maps, tables, whatever, our end result of our analysis, it's all going toward, uh, uh, getting money to these people. And really what that means is our stakeholders, it's not the people where the money's going to, but it's really, we want to focus on these government officials, the politicians, whoever gets to write the check and send it to whatever, Mississippi county we're sending stuff to. Now, like, no offense to politicians and people in charge of things, all wonderful people. But what I've found in my past work experience is when I'm making maps or tables or whatever for the general public versus going for, people in positions of power and with authority, I tend to dumb down my stuff for the people in positions of power more so than I would for the general public. And that, a lot of people say, like, oh, public's so dumb and you gotta, simplify things because people are stupid. Give me the public any day, right? When I'm dealing with some important person, they're not going to read anything. They're not going to look at a legend. They're not going to take time to think about what's going on. They need it just spoon fed to them. So that's what I would take from this. And what I would want to think about is, okay, my end deliverables, this term we'll get into in a second here, with these end deliverables, they need to be, easy to follow, colored, like what you would do for a toddler, basically, right? Not a lot of attention span with this stuff. Make it very clear. That's what they're getting at here. Now, these authors might not be trying to say or weren't implying that people in charge are toddlers. But I'm saying that. I'm not even implying it. I'm saying it, dumb it down. Okay? Do good analysis and results, but keep in mind, nobody's going to care about the analysis you did. They just want nice, easy to follow information at the end. Okay? It's a little depressing, but hey, c'est la vie. All right, and then deliverable here, this term refers to what you're actually producing. It's another industry term, buzzword, but it means, at the end of your result, are you going to deliver one map, 5 maps, a table, something along these lines? Maybe your end deliverable is actually a report, like some document that you have, some 20-page analysis of your results, right? Whatever it might be, what's that end thing that you're producing? And for this, they say we recommend the following. I like that they recommend it. It implies that you've got some power, some control, but really this is what they're telling you to do. Okay, but a map showing the elevation / bathymetry of the Mississippi coast, these specific counties with places, types of water, barrier islands, and hydrography. So this is kind of just a general reference map. Elevation meaning on land, differences in relief and how high up the land is. Bathymetry means depth. So it's like the opposite, yet also the same concept, but just going underwater. Okay? So that's the first one. Number 2, a map of flooded land of the Mississippi coast after Hurricane Katrina. So that's something we want to see. Definitely. Number 3, a bar graph showing percentage of total flooded land by land cover type. 4, a map showing infrastructure and health facilities at risk from the storm surge. And then 5, a table showing various land types that were flooded, measured in acres and square miles. So it's not all maps. There's some actual data analysis that's presented in other visual ways here. All right, so we'll follow through here. And like this reference map, not too crucial, but it is a case where definitely we want to see where the flooding took place, and some of this, percentage of flooded land stuff is key. So we'll go through that. Okay, we're following. Um, so you scroll through, it says examine the data. I've got some notes trying to help with this. Again, this was from ArcGIS Desktop, an older version of the software that you're using. And there's some different things like Arc Catalog was a separate, for a while, it was a separate program. Then it became embedded. And now within ArcGIS Pro, this is just the catalog pane. Okay, so it's like we have over here. Let me just minimize that. So catalog right here. This is Arc Catalog in that, as it's referenced in the tutorial. With if it talks about Arc Toolbox, it's in this Analysis tab up here. And we click on Tools and we can search for things right here. It used to be, it was a separate program, then it got embedded into the thing, but it's the same idea. Okay, so I bring that up, and I like having some of this old stuff because there's some good tutorials and information that are still based in ArcGIS Desktop, where if you don't learn how to kind of think about this stuff and work across this different type of software, all of this is lost, right? But if we just think a little bit, and of course, if you're really stuck, if something's not clear, if I don't get into it here, shoot me an email. We'll figure it out. So this examine the data is all about just, what do we have? What are we starting out with? And it has you, in theory, what you would do if you're following along is you would open up all of these different feature classes and rasters, and you would fill out this information, right? Data type, so vector, points, lines, polygons, raster, meaning some grid thing, vaster. That should be an R right there. The land cover and the elevation are raster. The other stuff is all vector. Data, time period data is relevant. 2001. I don't know if they're all like this, but that's good to think about, right? So the hurricane hit in 05. We would want to have data pretty close to that point in time to make it relevant. If we were doing historical work, it would be a case where I'd want to have some older stuff. I wouldn't want to have all the airports and churches and things like that. Hospitals from today, say like, a 2019 data set or 2024, or whatever it might be. We might have new stuff, right? I'd want something from the early 2000s. And if I'm working at that moment, I'd want the most up-to-date information as possible. So it's good to check that, just to make sure that one of these isn't like 1974. Spatial coordinate system, which you would find if you looked through all of this stuff, is basically this stuff is in some different things, some different coordinate systems. That's something we're going to deal with in here. So you don't need to fill this out, but this is good to just think about metadata, what you're dealing with in here, all of that kind of stuff. As we scroll through, we'll come back to the spatial coordinate system thing. But as you scroll through, so that whole part was just explore. Let's see what we got. Organize and document your work. Similar idea, and this is here. Let me go back to the catalog pane over here so we can see it side by side. This is what it's showing. The Arc catalog version, the older thing, but general idea. It's showing you where this stuff is being saved and where you should be saving stuff and all of that. We're going to do things a little bit different from in here, and I'm not going to be checking where you're saving this stuff, all of that, but it is important to be consistent with this. Take the time to get stuff set up, know where things are being saved, and all of that, right? It'll help you out. Typically, if you have issues, if you have problems with your work, things aren't working, you can't find stuff, et cetera, et cetera. It's because you weren't paying attention to these early steps. So I'm kind of gonna blow through here, mainly so I don't produce like 4 hours worth of video content, because you're not going to want to watch that. I'm not going to want to make it. But do read through this, right? Take the time to go through and see what are they saying. So this is simply getting into, keeping track of data, you know, where where's your stuff being stored? Okay, this is what we've done with this whole, in documents, ArcGIS projects, have the Hurricane project, move our stuff in there. That's the idea. Know where we're saving this stuff. This process summary is a good thing to get into in the interest of time. Again, I'm not going to go through this. I'm not going to force you to do it, but something to think about. This is going through your workflow. What am I going to do? What do I need to do first? What am I then going to produce? What am I going to extract from this? That kind of stuff. This will be listed for you in the tutorial, but if you're doing your own work, this is a good way to think about stuff. Okay, and then document the map. This gets into some older structural stuff. ArcMap, again, separate program, part of this older thing, but they had this document properties deal. And the idea is you would get in and put in metadata, right? Data about data. You'd have, like, what's the purpose of this map project that you're doing, right? Keywords, categories, comments, who did it, all sorts of things in there. It doesn't exist quite in the same way here anymore. Instead, in ArcGIS, go to project, right? And in this project thing, click on info down here, which it's already set to. And within info, that's where you can set this stuff up. And there's no summary for this item, there's no description. I haven't done anything here, but if you click edit metadata, you can come in and you can add these things, give it a title, right? Tags, keywords, summary, what are you doing? Why are we doing this? Description, a general abstract, the thing, kind of the same idea. I think this is supposed to be a little more robust. The description, credits, who did it, different limitations and all that. That's what it's asking for you to do. I'm not going to make you do it in here. I'm going to move past that. But that's really useful if you're working in this stuff. If it's not just a class and you're just kind of playing around and experimenting with stuff, but when you're working in an office, especially with multiple GIS people, you're going to work on a project. And then, months, if not years, are going to go by, and somebody's going to ask you about that project. And you're going to go, yeah, I had some maps and some stuff I did. And you're going to pull it up, and you're going to look at it, and you're going to go, I don't know what I did, right? I have no clue what the purpose of this one was, or the 8 other map projects that I had, or like within this whole thing, you might have multiple maps within here, and if it's just map and map 1, map 2, map 3, and so on, you're going to go, I don't know, and you might have to redo everything. Be obsessive with this, with documenting these different things. It'll help you out down the road. And again, we're going to breeze past this. It's kind of one of those, do as I say, not as I do things. But it's important to be doing this stuff. Okay, so what we'll do here is with this environments, that's key, but we want to do some other stuff first. Let's go back up to, I'll set you up with this, and then we'll stop this video and I'll start another one. This whole spatial horizontal coordinate system. What coordinate system is this stuff set in? We've dealt with this before. in the other classes. And one thing we want to do here, let me go back to this with all our Katrina stuff, is we want to have everything projected, not using one of these geographic coordinate systems, but specifically projected, and all projected in the same coordinate system. And I've been kind of lax in other classes with this stuff, but with spatial analysis, when you're doing that, fundamental, one of the first things you do is you look at the data you've been given and you make sure it's all projected into that same coordinate system. And just, refresher, I'm sure I've talked about this previously, but the reason for that is because it's going to limit all of the math that's going on under the hood of ArcGIS. The stuff that it does on the fly, it's good, it's pretty impressive, but it's a little fast and loose, right? In trying to make sure that this thing that's projected in this coordinate system, this one that's stored in the geographic coordinate system, making sure that they line up. The math it uses is just enough to kind of get it going quickly and give you a nice visual presentation of the stuff. But when I'm getting to the point where I'm actually overlaying data and I need to know exactly where these things are and how they relate to one another, I don't want to rely on the fast and loose on the fly stuff. I want to have everything projected right off the bat. It's going to take its time. It's going to fix it in place where it needs to be, and it's going to ensure that my results that I get are as good as they could possibly be. Okay, that's the main thing, is that I'm making sure that if I get some answer, it's as good as I could possibly get it, and I'm not going to be embarrassed when it turns out that, yeah, this table I turned in, the analysis of the data was actually sloppy and it was wrong. Okay, so that's what we want to do. So I want to have all this airports, churches, counties, all of this stuff right here. I want to reproject it. I'm going to put it in this hurricane.gdb, which is empty, but I can just do this just to be set. Let's do new feature data set. I'm going to call it, let's see, we're doing Katrina here, so I'll call it Katrina just to start with. And with my coordinate system, I want to go into projected. I'm going to do UTM because I love me some UTM. I'm going to do North America, and I'm going to come down to NAD 83. Okay, and I'm going to do zone 16. And I'm sure I've discussed this in other classes. Maybe I have, maybe I haven't. But the zones are based on the way UTM is just set up, and you work in these specific zones to make things more accurate, to limit distortion from the whole projection process and all this geographic theory stuff. So like in, let me move this in California, we've got zone 10. It's basically if we follow this line here and keep going down, all this stuff in the northwest is zone 10. Zone 11 is our Southern California stuff down here. Follow the straight line of our border. That's 11. 16 is over here, and it's got New Orleans as well as Mississippi covered here. So that's where we're going to use this one. Okay? We could use anything that would work. I just like UTM, so I'm picking that. And I'm going to hit OK. And I'll just, let's just call it that. So now if I go back in here, I've got this Katrina data set, and that'll be something I can use to project all of this stuff, right? And so if I go back to tools here, I'm pretty sure we've done this before. Batch project. That's what I'm going to do. I'm going to move it's kind of a review, but kind of moving quickly because I hope that you're comfortable with this stuff by your, third class of the certificate. So in here, I'll go ahead and hit browse, folder, Katrina. I'm going to select, it's going to give me all of the vector data sets. Rasters we're going to have to do separately. Okay, but I'm going to grab all of those. I was just, left click the top one, shift, left click the bottom one, Hit OK. Output workspace. Let's do the little browse. Let's go to hurricane. I want it in Katrina. Let's see, output coordinate system. I guess I'm gonna have to go back. There might be a more eloquent way of, or elegant way of doing this, but eloquent. But whatever. I'll just go back and select this again. Again, moving kind of quickly. Pause, rewind if you need to. But what I'm saying here in this batch project is take all of these vector things from the Katrina thing, put them in our new Katrina data set, and make sure it's in this output coordinate system. The other stuff I'll leave blank. I'm going to hit run. Say a little prayer, hope it works. Just keep going. And so I want you to do this, get these things projected there. The other thing I want you to do, beautiful, and it added it in when it worked, gorgeous, is we've got this elevation is a raster. You can see this little grid pixel looking thing. And land cover is also a raster. Unfortunately, this batch project doesn't work. Let's see, hold on. Let's go to tools. But we can project raster. Okay, and in here, we're gonna have to select one at a time. Let's see, so Katrina will do elevation. Hit OK. Output coordinate system, I should be able to, yeah, just hit the drop down, hit any one of those, and it gives me that. The transformation, I don't think I need to worry about any of this. Resampling technique, cells, all of this stuff, we're going to leave it as defaults right now. I'm going to hit run. Oh, wait, except, dang it. Stop. Hold on. Output, this is what I forgot because I just filled it in. So yeah, that's throwing it in. So we don't want to call it eliv underscore project raster. Okay. So let's do. So I got that data set. It's not going to fit in there. Let's instead call this eliv Katrina, because I think the Wilma one is going to have that. Okay, we'll hit run. See if that works. Beautiful. And we've got this DEM. And so what I want you to do then is do the same thing for land cover. Okay, call it, land cover Katrina. Same stuff there. Hit run and then save what you got. Okay, I'll stop this here, and the next video we'll get into other parts of the tutorial. All right, so run this. Happy mapping. See you in the next video.